All right, let's talk a little bit about how to use scatter plots and how to do this bivariate linear regression inside of Excel. I personally prefer Excel a great deal over our calculator because we're able to see our data pieces so nicely. I've got the same things that we just saw on the whiteboard recorded here into Excel. And the first thing I'm going to do is talk about some of the data that we are used to getting out of pieces. So if I right-click on a column and click Insert, I can get an extra column over here on the side. And maybe down here I'd like to code in some things that it might be interesting to talk about the mean. It might be interesting to talk about standard deviation of the samples and any other data that we might be curious about. Excel, of course, has the ability to talk about mean. It uses the word average, which I admit I don't like a little bit, but that's just the normal arithmetic mean we've been talking about. And so I've hit in equals average, and then I'm clicking on my mouse and highlighting all this information here, and I close the parentheses off, and we've got ourselves our calculated average for this piece. To make it match up with the calculator, how it was going, I'm going to go ahead and add another decimal place there by clicking on the home ribbon and this increased decimal piece. And now notice once I've done that, notice how currently my mouse pointer is sort of this open, empty cross, and if I hover over the right corner of the thing, it suddenly goes into the right corner of the cell. It becomes a solid little plus sign. If I grab that and drag it to the right, this is called the fill handle in Excel, and it will go ahead and automatically copy over into the next column cell the average equation, but it will recalculate it for column C. This fill handle is very convenient in Excel because it gives us the power to select and type out an equation once and then rapidly apply it to several columns of data. If we want to do standard deviation, we can type in equals standard, and as soon as you start typing in things, it'll give you there. Here's standard deviation.s for sample, standard deviation.p for population, so we could select that information. Again, maybe here for this linear regression, we're not very interested in that, but it might be interesting still, like I said, to be looking at that mean, because we do care about the x bar values here. Those are interesting, x bar and y bar for each of those pieces. We saw those when we were drawing the scatter plot initially. What we were first interested in doing is looking at this information and taking a look at the scatter plot. In Excel, you can highlight your data. Notice in my first column, the top column here, or excuse me, the top row, we've picked hours per week and I've typed in score, and it's convenient to type in those words because when Excel makes the scatter plot, it will make it pretty nice for you. I go to the top of the ribbon and I click on Insert, and we go over until we eventually find chart areas, and we're trying to select scatter plots. I'm just going to select the most basic scatter plot we've got, which is this top left one. You could get ones where it tries to do various fits to the lines, and that's nice, but let's just go with a pretty straightforward scatter plot here. Notice this is much more nicely drawn than I was able to do by hand. And again, we can kind of see that as we move from left to right, this sort of looks roughly like perhaps a linear equations coming out of this. If you then hit on this plus sign, it will depend on your version of Excel. This is Excel version, I think, 2013, 2012? I don't know what version. This is the latest version of Excel that I've got here. Older versions, when you switch, will have the same chart tools thing at the top, but they'll have just a little bit more data. Maybe I should just mention exactly what that looks like. In the first, you'll get your chart tools, and there will be not just design and format, but in between those will be a layout button. And a layout tab in between here, you would click on that layout tab, and then maybe about midways to the right, there will be a little box called trend line that you would be interested in. In the latest version of Excel, this one, if we click on this chart elements and go down to trend line, we access it in here. And either way, if you are in an older version of Excel and you have this button tab in the chart tools between design and format that's called layout, you can go to trend line and you'll select more options, or here I've gone to trend line and I'll select more options here as well. And Excel actually can fit many types of trend lines, but the one we want is linear because we're doing intro statistics. And some things that we normally like to add is we like to add the display the equation, and we also tend to like to display the r-squared value on our chart. Remember, we talked about r-squared value, and that was that coefficient of determination that we had talked about and discussed that explained how much of the variation was based on our line. Notice that we in Excel get the same formula that our calculator was giving us when we had put those data plots in, and our calculator also had given us the r-squared value when we did the linear regression feature of it, and these numbers are all matching up. So that's maybe a good thing. This is a scatter plot, and this is now our line equation. The only thing I kind of dislike about Excel is it doesn't label this a y-hat, it just calls it y. But other than that, it's very nice because it gives a very decent input of that line, and it it calculates the r-squared value for us right away. So I think that's maybe very helpful here. Let's look at some other things that you can do in Excel. If you go ahead and click on the Data tab of the ribbon, then over here on the right you will see this Analysis tab that I have. Your version of Excel may not have activated that. However, if you go to File and go to Options, you can select and look at add-ins, and you can go down here and hit Manage Excel Add-ins. There's some different options you can select, but we can manage Excel add-ins and click Go. And what you're going to want to add in is you're going to want to select the Analysis Tool Pack and maybe the Solver. Those are the two I usually add. I also do some scripting, so I have the Analysis Tool Pack script. But either way, I think Analysis Tool Pack is the one you want. And then you'll click OK. And when you do that, then if you were to click on your Data tab, you would see the Data Analysis and Solver buttons pop up. By default, Excel tends to have those disabled because they tend to make the startup time take just a little bit longer. What we want to do now is click on Data Analysis, and what we would like to do is sort of scroll through here and see all the different things we can do, but we're mostly interested right now in doing correlation. So I'm going to select correlation and hit OK, and then I'll go ahead and select these two columns here. I'm going to tell Excel that I'm grouped by columns, and I'm going to tell it that I've got labels in my first row. I'm also going to tell Excel that I'd like to output in the same sheet of Excel that I'm in. Make sure when you select output range that you also tap your mouse in this region here, otherwise you will just unselect your input range. That would be sad. But when you select this range right here, then you can tell Excel that you'd like to fit this information in this part of your graph. Hit OK. And notice Excel has given us some interesting information down here. Notice it's kind of crunched in there. It didn't do a very good job of filling out the size of these columns. That's okay. Follow my mouse pointer up. It's looking like that empty cross, but now I hover it over between the two columns, and suddenly you see it's got little arrows. If I double click and hover here and double click, it spaces out just as much space as it needs so I can see everything. And what you see is the correlation coefficient. And the correlation between hours per week and hours per week is 1. And that makes sense. It's a perfect match for hours per week to hours per week. You'll often find many programs that don't write the ones down the diagonal. They just put little dashes. Oops, not things, just little dashes. And that's how they show that there's no real point in talking about hours per week and score to score. Excel does ones, and that's pretty common as well. And right here we see our correlation coefficient. Remember on the board when we had done this, I had rounded it to 2 decimal places. Again, if you go back to the Home tab and select that, you can decrease the decimal places to as few as you like, and if we decreased it to 4, we would have the same rounding that we had there. And if I increase it back again, you'll notice that your calculator had calculated the same pieces. Pretty much the same level of accuracy between the two for any problem that we're doing. And this was that number, again, the correlation coefficient, this number here, and that was the number that we said could live between -1 and 1, and the closer it got to +1, the more we would believe that it made sense to talk about a linear regression line. So this is how you do a calculation of a scatter plot in Excel. And overall, this is pretty decent for what it does. And I had grabbed these hours of weeks, and I had just found some things for them and calculated them out here in this sheet too. You can add different sheets to Excel, and that's entirely possible. We'll do a little more playing with Excel in a bit. And I think that the real thing to focus on is that maybe unlike other software, or maybe not maybe other software, but certainly other calculated software, you can do a lot with Excel and make things very interesting. So let's click on maybe this design. We can play around with the design quite a bit in Excel, select different things, and you can select the colors that you're interested in. And this gives us quite a bit of power. You can even change the layout to different shapes and designs, and so you can have all the individual raw data points put on there under layout 5, where you can keep it pretty simple and straightforward, or you can try to have a lot of a grid and try to show exactly how this is all going. So there's a lot of power in Excel in terms of being able to create something that I think is sometimes pretty fancy looking. And maybe a real powerful thing that one can do is if one opens up PowerPoint and perhaps creates a new presentation. One of the real interesting things that Excel and PowerPoint do, and I always sort of encourage students to play around with this, is that if I right-click on this chart here and copy, I can successfully paste that image here into Excel. Let me actually copy it. Copy it as a picture. I can paste this into PowerPoint, and it makes it very easy to create some decent charts and graphs that can then easily be presented, and I can present this data to people in a very decent format. So if I'm giving a talk about something, Excel is very intuitive in how I take things from calculating out the raw numbers to successfully pasting maybe a picture, and I can show people that inside of PowerPoint, and it makes it very, very neat and straightforward overall. So that's good enough, I think, for single regression. Let's just look at a couple things that are convenient about how Excel works. And maybe I'll try to get rid of that painfully lurid color that is even offending my sensibilities, and I'm colorblind. Let's make it a little bit, I don't know, this seems a little less bright and in your face, and maybe a little more straightforward. Who knows, maybe that contrast is bad. Excel is very interactive. So let's look at here. We had talked in the video about how these two students were interesting because they had spent the same hours per week, but they had gotten rather different scores. One was barely in D territory, and one was at the high end of C territory. And your textbook talks a little bit about formatting the numbers. In particular, it talks about outliers. So let's look at the outliers. And notice if I hover over this point, we can see that this is the point 2,1 and 5,4. And this point is very far away from the line. This line is a very good fit in these points here in the middle, but this one right here and this point up here are very strange and different. And we can find these 2 points right here in our data. These are also interesting. Only 0.1 hour difference between them, just a few minutes. And yet one student scored a 54% and one student scored an 88%. These points might rather be outliers, and you have a specific formula for doing that in your book, but one of the beauties of Excel is that it's very easy to change things. Notice I just deleted those, and maybe I'll undo it and highlight that. So they're highlighted, I hit my delete key, they go away from my data, and Excel automatically recalculates the mean. But notice also on this screen, watch over here, I'm going to hit undo. My R-squared value is 0.1898. When I delete those, we have a change in our y-hat formula. we also have our r² value changed to 0.31. That's because those terms were outliers. They made everybody different. Now, very much, you have to be careful. You can't just go and delete data points just because they make your line fit increase drastically. That's not a good and wise thing. As an extreme example of this, notice if I delete this, and then if I delete some of these higher values here, let's see, what's this one down here? This is the 3161, so I can delete that. And then this is a pretty high value up here, so I could go here. That's the 586 one, basically anything that's not quite fitting in the range. Oh, now it's even zoomed in on the chart, so now I can start to get rid of even more things. What you're going to find is if you get rid of enough points, your r² value is going to start to get really good. So now I can get rid of this 23. Now we're up to a 32%. Let's get rid of that point here. In particular, in a very extreme example, if I was to delete all sorts of points, but look at my r² right now, 0.52. This means that my r² line is starting to make a really good fit with the points that are left, but I've destroyed a lot of my raw data. I no longer believe that this formula is all that accurate because I've gotten rid of so much of the raw information that really describes how hours per week works with students. If I looked at this formula using just this amount of data, I might think to myself, oh, the hours per week spent and scores are very much related. But if we actually add in all the data back, we can see that really, while there is some connection between hours per week and scores, it doesn't explain all of the variance. And we had again talked in the video where I was still in front of you face to face, why that might be the case. The fact was that if we were looking at this, I had talked about how these two students, I think in particular, maybe one of them has been several years since they've taken a mathematics course, and this one just got out of calculus. Same thing might be happening here. We might see a student who is doing very similar hours a week per work and very different scores. Or maybe this is hours per week spent just in the homework program, and so this student only spends 2.1 hours completely, whereas this student secretly is reading the textbook and working practice problems in the book, and so by the time they're ready to do their program, work online in their homework, they still only spend 2.2 hours, but all that other work is paid off and given them a rich reward in terms of the grade that they're able to earn. So you can't just delete data, and that's where you have to be very careful when you look at the textbook section that talks about deleting outliers. It's not good enough to just start deleting all the things that don't seem to work until you seem to get a line that fits very well. That's not the correct way to handle data. Anytime you delete a data point, if it's an outlier, you have to explain why it's an outlier and say that you're deleting it, and you need to be very, very careful about that process. That, I think, now truly does wrap up what we want to talk about for Excel with two columns. One column for our response and one column for our explanatory data variables. I guess our response and our explanatory columns here. An independent column for hours per week and a dependent column for score. Let's now next see an example in Excel where we've got more than a single column predictor. What if we had hours per week, and what if we had something else that helped us predict how students were going to score on their homework? Maybe something that talked about time since their last course, like we discussed on the board. So this video, I think, is over, and you'll see that just the next one.